Good morning. This is a optical fiber communication lecture, and it's a first lecture of this subject of electronics and communication engineering branch for fifth semester students. The name of the today's topic is the historical perspective and the basic communication system in optical communication and the optical frequency range useful for optical fiber communication. So, first of all, what do you mean by communication system? So, communication system is a system which is designed to transmit and receive the information. So, what is information? Information can have any form. It can be an audio information, it can be a video information, it can be a light source, or whatever. It can be temperature. The information has many forms. So if you want to transmit any information from one end to the other end, then we require a system which is known as the communication system. So communication system is a way to transmit multiple information from one end to. So inf- as shown in this picture, the information source is given to the communication system. So it passes through this communication system and it is available at the output. So whatever the information is passed on to a communication system, it is available at the output of the communication system. This is a general block diagram of communication system. As you can see, the information is passed to a communication system. It can have any form. It can be a audio information, video information, temperature, pressure, or whatever you think. It is first given to the input transducer. The transducer, what do you mean by transducer? Transducer is a device which converts one source of information into an electrical signal. Example, it converts temperature to an electrical signal. Why? Why it is converted into an electrical signal? Because we can process the electrical signals. Whatever I am speaking on microphone, it is first converted into an electrical signal by an transducer. Then it is transmitted, it is passed on to a transmitter. From transmitter it goes to a transmission channel. There can be n number of transmission channels. Example, wired, optical cable, wireless. From the channel it goes to the receiver and it is available at the output. So example, suppose you are talking at your own mobile, so your voice goes to the transducer. So whatever you speak, it is converted into electrical signal. From your mobile set, this electrical signal goes to the antenna. From antenna, it uses a wireless channel and it goes to the antenna of the mobile tower. It goes to the mobile tower. So whatever the channel is there between your mobile antenna and the mobile tower, that is a channel and it is a wireless channel. From that antenna, it goes to the mobile at the receiving end. Example, your friend. Their antenna, it picks up the electrical signal, it processes it, and its speaker converts the electrical signal again back to a sound. So whatever you speak at the transmission end, it is available at the speaker of your friend. So this is the general communication system block diagram. The information can be your analog signal or it can be your digital signal, but the process is same. So there are various components of a communication system. The first is input transducer. So transducer is a device which converts a physical signal to a physical signal. Example, it converts my sound to an electrical signal. For thermometer, it converts temperature to an electrical signal. For camera, it converts the optical signal or the image signal into an electrical signal. Okay, so transducer is a device which converts physical signal into an electrical signal. The second part is the transmitter. So it is a device that sends the electrical signal to a channel. So whatever the output of the transducer is there, it is transmitted by a transmitter. Next is transmission channel. As I already told you, we require a medium to transmit the information. So medium can be your wired medium or your wireless medium. For mobile, it is a wireless, but sometimes we have wired medium. For optical, it is a wired medium. Receiver. It is a device that recovers the transmitted signal from the channel. So whatever you speak from your mobile, when it goes to your friend or your parents or whatever any person to whom you called, the speaker at the receiving end recovers the original information from the transmitted signal. Okay, so output transducer which converts the electrical signal back into a useful quantity. Example: suppose you are talking, your information is a sound, your speech, whatever you are speaking. The output transducer will convert electrical signal back into a sound or your speech. For for camera, the transmitter transmits the optical signal and at the output transducer, it is again converted back into a picture signal. So basic analog communication system. The first part is input transducer, example your mic. So the transducer converts into an electrical signal. The second part is your transmitter. Has a modulator. Modulator means we require a modulation. Modulation of input signal is done with the carrier signal. So carrier, the information of the carrier is modified in accordance with the input electrical signal. So carrier characteristics are changed after, and this is known as the modulated signal. So output of the modulator is a modulated signal. The modulated signal goes to the transmission channel. So transmission channel can be your wireless or wired. From transmission channel, it again back goes to the receiver. The receiver demodulates. So whatever you modulate at the transmission end before passing it to transmission channel, it is the reverse process is done at the receiver end, and the reverse process is known as demodulator. So at the transmitter it is modulator, at the receiver it is demodulator. So at the transmitter we do modulation, and here demodulate. So after demodulation, the original electrical signal is acquired. So as you can see, the input transducer is a mic. So whatever you are saying is passed on to the mic. And at the output transducer, there is a speaker. So whatever you speak at the input transducer, the same is available at the output transducer. Digital modulation. We have two types of modulations. One is analog modulation, in which the modulation techniques consist of amplitude and the frequency modulation. The another way of modulation means to change the characteristics of the carrier is by digital modulation techniques or digital communication techniques. Okay, and these techniques consist of amplitude shifting, ASK, frequency shifting, FSK, and the phase shifting, which is PS. So information source, let us suppose we have a message M of t at the left hand side. This message is passed on to transmitter. So the output of the transmitter is S of t. After modulation, it is passed on to the channel. During the channel, some noise is added from the environment or atmosphere, and at the output of the channel, a signal is received, which is R of t. So R of t will have two components. One is S of t, transmitted signal, plus N of t, noise signal. So noise is added at the received output signal. So from received output signal, the information which was M of t at the transmitter, it is recovered back after removing the noise from the channel. So, so we require a process to remove the atmospheric or external noise available in the channel. So telecommunication. There are different ways of telecommunication. Initially, I will start with telegraphic signals. So at the start, we were using telegraphic signals. Then we have fixed line telephones, okay, which are available at your homes or government offices. We have cables, we have wire network, we have internet, which you are using. And for internet, today fiber communication is used because it has many advantage. Communication bus inside computer to communicate between CPU and memory, because the information is required to be passed between various components of your computer. Example, from memory it goes to the central processing unit. From central processing unit, it goes to the output side or from memory side. So for all that, we require the buses. So buses means the wires that carries the information from one part to the another part. Then important part is how transmission is done over a medium. Example, uh, in a class, when a teacher speaks and all the students they are listening, They are not giving any question, they are not putting any question, they are just listening to the teacher. So that is a simplex way. So simplex means only one way direction signal flow. Then we have half duplex. Half duplex means the teacher and the students they can communicate both way in a class. Teacher is giving the answer and the students can put the questions from the teacher and both are interacting at the same time. So travel in either direction but not both direction at the same time. So when teacher is speaking, no student should speak. And when the student is asking any question, the teacher should listen to the question. If this is a way, then it is a half duplex. The third part is full duplex, means we can transmit the information or we can travel the information in both the direction, in either direction simultaneously. Example, now you are using full duplex mode of operation in your mobile, means teacher is speaking in the class, at the same time the students are putting question to the teacher. Teacher is saying, student is saying, student is saying, teacher is saying. So this is full duplex, means in a single time, simultaneously, both are speaking to each other. So this is a full duplex. So present day telephony is using full duplex mode of operation. Half duplex example is you can you can see the policeman holding wireless talk, talkie set. So when the policeman is speaking, the control room is listening. But when control room is speaking, the policeman is listening. So that way is half duplex. And example of simplex is your TV transmission. Okay, the news channels are simply transmitting their news, and we are in listening mode. So that is a simplex mode of operation. Walkie-talkie is an example of half duplex, and present-day mobile telephone is an example of full duplex. So I think I have explained it in detail. The term transmission mode defines the direction of flow of information between communication devices. So there are three modes: simplex, half duplex, and the full duplex. So this is a simplex mode in which the CPU is transmitting and the monitor is just receiving the signal. Monitor cannot give the information to the CPU. So this is a simplex mode of operation. Similarly, from the keyboards, we can give the information to the CPU. So any information from the keyboard to the CPU, again it is simplex. The second, the from CPU to the monitor, again this is a simplex mode of operation because we cannot send the data from CPU to the keyboard and from CPU to the from monitor to the CPU. So this is a so half duplex. As you can see, when A is sending, B is receiving. Okay, B cannot send it. The lower part, When B is sending, A is at the receiving end, and A cannot transmit this information. So walkie-talkie operates in half duplex mode of operation. It can only send or receive a transmission at any given time. It cannot do both at the same time. Full duplex. Full duplex means we can transmit data both way in both directions at the same time. Full duplex mode is used to transmit the data over serial communication link. So two wires are needed to send the data. Okay. So full duplex transmission, the channel capacity is shared by both communicating devices at all times. So here both devices can transmit and receive the data at the same time. So it is a bidirectional. So example, I already told you your present day mobile telephony. Okay. So it is a example of full duplex. Now, what are the media? I already told you there are two different types of media. One is wired, another is wireless media. So one of the wired media is coaxial cable. So you can see cable TV available at your home. So which cable goes to your TV set? That cable is known as a coaxial cable. So it has a copper wire basically, and outer then there is a insulation, then copper mesh jali जिसको कहते हैं copper mesh is there, then again insulation is there, black insulation is there. So information is carried by inside copper wire and the copper mesh. So uh, whatever the cable TV signals goes to your TV sets, it is coming to your house through coaxial cable. So largely replaced by twisted pair of networks. Your cable TV, thin Ethernet and thin Ethernet, they are basically useful for networking media. Then we have unshielded twisted pairs. Twisted pair means there are two wires set of a pair. Uh, Many wires can be there. They are basically consist of copper or aluminum. They are there are certain advantage of these twisted pairs. They are inexpensive, easy to terminate. They are widely used. They support many network types. This, but at the same time, there are certain disadvantages. They are susceptible to interference. They are prone to damages during installation. We cannot use those twisted pair for a longer. Then the important category of guided media is optical cable. That is known as glass media. Basically, silica material is used to make the optical cable. Okay, there are various types of optical cable, single mode fibers and multi mode fibers, depending upon the usability. The advantage is they can be installed over longer distances, so they can provide large amount of bandwidth. They are not susceptible to noise or interference. They are highly secure. They cannot be trapped, but at the same time, there are certain disadvantages. They are expensive, and the installation procedure is rather uh, tedious or difficult. So simply non technical person cannot uh, be useful for used for the installation purpose. So highly skilled labor is required for the installation. So these are the disadvantage, but the advantage is more. Means large amount of bandwidth required is possible. So whatever you want to transmit, it can transmit through this cable. Another is very secure. Nobody can tap your signals. it is susceptible to electromagnetic interference. So no noise will be fixed. So your information will be available at the output without noise. And there is no loss is there. It means you can transmit the signal to a longer distance without. Uh, Wireless transmission through the space of electromagnetic waves is known as the radio waves. So the frequency range is 10 kilohertz to 300 megahertz. So whatever you speak to your mobile sets, so your mobile sets use wireless transmission. So it uses your radio space for your media. So these are the examples of wireless media. Uh, Mobile set antenna transmits the information to mobile towers. Then it is passed to the Ethernet, and at the thing, and again it follows the process. So there are the different connectors useful for optical connections. Okay. Important part is the band. There are various bands. VLF, very low frequency, medium frequency MF, at high frequency, very high frequency VHF, ultra high frequency HF, super high frequency SHF, extra high frequency EHF. But after the EHF, then the spectrum comes under the IR ranges, and this is the band which is useful for optical communication. So 300 nanometer to 500 nanometer, 1500 nanometers, basically in this spectrum as shown in this picture. It comes under IR band. From IR band, we can use this this wavelength for optical signals. So, what is the optical fiber? Optical fiber is a transparent fiber that acts as a waveguide, and we can pass the light from one end, and it is this light can be acquired at the receiving end. So, for fiber optics, we use fiber media. Okay, so we can send the transmission to a longer distances and at higher bandwidths than the other modes of communication.